Solid system equations for x and y. These ones are non-standard form, so first we have to do some preconditioning to get them into standard form. So let's put them in here. So we're going to expand this guy here 2 times, and we'll multiply both sides by x plus 5. So we'll get, oh, we have to write down, first we'll write down what we're going to do. Simplify equations 1 and 2. So we'll get 4x plus 4y minus 2y equals 2x plus 10. Okay, bring all x's and y's to one side, leave everything else on the other side. So we're going to left with swoop 2x plus 2y equals 10. So there's one equation. We'll call that equation 1a. Still equation 1, just modified a little bit. Now we're going to take this guy and we're going to simplify him. We're going to take the 7 minus 4, we're left with 3, multiplied by that guy. So we're going to left with 3x minus y equals 3y minus 3x. Bring everything to one, bring all the x's and y's to one side, leave everything else on the other side. So we'll be left with 6x minus that. I'm going to be left with minus 4y is equal to 0. And there you go. Now we're back in the standard form, equation 2a. Let's put this into matrix form now, okay? Into matrix form, can I shove it down here? I think I can. Into a matrix, it would look like this. It would look like 2, 2 times our x, y is equal to 10. That's our first equation. Our second equation would be 6 negative 4 times these guys equals 0. Okay? And now into row echelon form. So that's into matrix form. Now let's actually solve this thing by hand, which we'll put into row echelon form so we don't have to carry any of the variables with us. We're just carrying numbers. And we'll start doing row operations. So first things first, I would like to make that one a 1. So we are going to take row 1 and divide it by 2. Row 1 divided by 2 will give me 1, 1, and a 5. And now we're going to get rid of this one. We'll make this one a 0. So we're going to take row 2 minus 6 row 1 new. I'm talking about the new row 1 and not the old row 1. I could take row 2 minus 3 times row 1 old, or I could just talk about the new one, which is more commonly done because we have a 1 there, so it matches that coefficient. So 6 minus 6 times 1 is 0. Negative 4 minus 6 times 1 is going to be minus 10. And then 0 minus 6 times 5, it's going to be negative 30. Negative 30, okay? All right, let's do our next row operations here. So next thing I want to do is I want to make this one a 1. I'm going to go in this pattern here, okay? We're going to follow this. So we're doing our forward elimination. We're going to end off with this diagonal being a 1. So we're going to take row 2 divided by negative 10. We're going to get 0. 0 divided by negative 10 is 0. Negative 10 divided by negative 10 is 1. Negative 30 divided by negative 10 is going to be 3. Great. Now let's change this guy to a 0. So all here we'll have to do is multiply. We'll take row 1 minus row 2. 1 times row 2, right? 1 minus 1. So 1 minus 0. Oh, row 2 new. Oof, let's be careful with that. Row 2 new. I'm talking about this row and not talking about old row 2. So I'm talking about row 2 new. Row 1 minus 0. 1 minus 0 is 1. 1 minus 1, 0. 5 minus 3 is 2. We have our solution. We have the identity matrix, or the identity A part of the matrix. So we can convert this back into matrix format, which will give us a 1, 0, 0, 1 with an x and a y, and it's equal to 2 and 3. And we can finally put that back into equation format, which will say x equals 2 and y equals 3.